Good day everyone. In this video, we're going to tackle about power theorem. In this lesson, we shall consider the relationship involving intersecting chords, intersecting seconds, and the relation of the length of a tangent segment and the secant segment intersecting at an exterior point of the circle. So we'll be tackling three power theorems. The intersecting segments of chords, power theorem. Power theorem number one, the intersecting segments of chord power theorem. If two chords intersect inside a circle, then the product of the length of the segment parts of the chord is equal to the product of the lengths of the segments of the other chord. In the illustration, there are two chords that intersect at point Q. This point Q divide each chords into two segments. In this power theorem, once the product of the two segments that is created by the intersection is equal to the product of the other two segments created by the intersection. In this case, AQ multiplied by BQ is equivalent to CQ multiplied by DQ. So now let's try to answer a problem involving this kind of theorem. So as you can see, in circle G has a diameter of 13, and if EC is 4, FC is 9, and the diameter EF intersects the chord AB at the midpoint C. How long is the chord AB? Now this is the midpoint of AB, so therefore AC and CD are congruent to each other. So we don't know their length, but we know that they are congruent. So we will mark them X. Now we know the relationship that EC multiplied by FC is equivalent to AC times BC. So therefore, we have 4 times 9 is equal to x times x. 4 times 9 is 36, and x times x is x squared. Now we get the square root to get the value of x. So technically, the square root of x squared is positive negative 6. So that gives us a length of 6. X is equal to 6. So the square root of x is 6. Now let's find the measurement of AB. Now we know that the measurement of AB is equal to 2x. That is, x plus x is 2x. So AB is equal to 2x. Now let's substitute 6 to 2x, and that gives us the value of 12. So AB is equal to 12 decimeter. The next question is, using the same figure in the first example, so we have the same figure here. If AB is equivalent to 24, therefore AC and BC is equivalent to 12 into 12, because that is the midpoint. The diameter was intersect AB at the midpoint. Then FC is equivalent to EC, so therefore 3EC. So therefore we have this as our equation. EC, we don't know what is EC, but we know that FC is 3EC. So we have this equation. Now we're going to multiply both EC and FC, that is equivalent to AC times BC. So we have, if we multiply that, 3 EC squared is equal to 144. Now let's divide 144 into 3, and 3EC squared into 3. Then we have EC squared is equal to 48. Now let's square root both sides. Then we have EC is equal to the square root of 48. Now we don't have an exact value for the square root of 48. We'll have to come up with a decimal values for this. So for this, we're going to simplify this by simply factoring 48 into something that there is a perfect squared, and that is 16 times 3. Now 16, we have 16 is a perfect square, so we can take out 16 out of the square root symbol or the radical symbol. Then we have 4. The square root of 16 is 4. That's why the measure of EC is equal to 4 square root of 3. Now we are asked to find how the measurement of the radius. We know that the radius is 1/2 of the diameter. So radius is 1/2 of EF. And we know that EF is equivalent to EC plus FC. Now we know that EC is equivalent to 4 square root of 3 and FC is equivalent to 3 EC, which is 3 square root of 4 square root of 3. Now let's multiply this one to simplify it. Then we have 12. So we have 1/2 of 4 square root of 3 plus 12 square root of 3. To simplify it further, we have 16 square root of 3. Now 1/2 of 16 is 8, so we have 8 square root of 3. Therefore, the radius is 8 square root of 3. Now in this part, we don't have any illustration, but only have a word problem. Let's try to analyze this in our brain. Or let's try to put out a circle so that we could analyze it. PQ and RS are, let chord PQ and RS of circle intersects at T. So we have these two chords that intersect on a certain point we call T. And this will be PQ and this will be RS. Now PT is x plus 1. Then QT is 5x minus 8. We have RT that is 3x minus 2 and ST that is x plus 2. Now and then we need to find x. So the relationship of this multiplied to this is equivalent to this multiplied by this. And that's how we solve for this. So we will use FOIL method to multiply both sides. So if you don't know FOIL method, please review your lessons on multiplying binomials. So I'll be doing one. X times x is by x times 5x is 5x squared. X times negative 8 is negative 8x. 1 times 5x is 5x. Then 1 times negative 8 is negative 8. So this will be combined like terms. 5x squared minus 3x minus 8. So this is the product of this one. So that is this. And this is the product of the other side of the equation. Now all we need to do is to put all of the variable things put all of them on a single side equation so that it will be equated to 0. 3x squared, so it becomes negative 3x squared. Positive 4x equals negative 4x, and negative 4 becomes positive 4 equals 0. So that if we simplify that, we have 2x, we have negative 7x, we have negative 4 equals to 0. Now all we need to do is to factor this out to find the value of x. Now let's equate both equations into 0 and we will know that x is equal to 4 and x is equal to negative 1/2. In this case, if we try to substitute 4 and 1/2 on each equation or each value of the segment, we can know that if we substitute 1/2 on QT, we will be getting a negative answer. Since we are dealing about lengths, there will be no negative lengths in a circle. That's why we will consider x is equal to negative 1 as an extraneous solution. So the value for x here is x is equal to 4. This one, let's answer this. It's just x times 8, that is x, 8x is equal to 4 times 6. And that will give us 8x is equal to 24, or x is equal to 3. So that's how this power theorem works. On the other one, we have 18 times 3 is equivalent to 3x times 2x. That gives us 54 is equivalent to 6x squared. Divide both sides by 6. That is 9 is equal to x squared. That is x is equal to 3. So these are the solution. Another example is this. We have this equation. X times x minus 8 is equivalent to 4 times 3. So we distribute this, we'll get this. We put 12 on the other side to equate this into 0, then we'll have a quadratic trinomial. Factor this out and we will get a value of x or values of x as 2 or 6. Now let's go to the second theorem, the segments of a secant power theorem. Power theorem 2, the segment of secants power theorem. If two seconds intersects in the exterior of the circle, the product of the length of one segment seconds and the length of the external part, meaning one length of the seconds and the external part, is equivalent to the product of the length of the other segment seconds and the length of its external part. So meaning QB, the external part, multiplied by QA is equal to QD multiplied by QC. That is how this power theorems works. So in this example, two second segments intersect from an exterior point B. As shown, what is the length of PS? So these are the given. So we know the relationship is PR multiplied by PQ, that is the whole segment, times the external part, is equal to PT times PS. PT is the whole second and PS is the external part. Now we'll need to find PS. So we know the value of this is PR is 12 and 8 is PQ, then 16 times PS. So that gives us 96. Then PS divide both sides by 16. We get PS is equal to 6. So the value of PS is equal to 6. In the figure, AC and AE are second segment intersects from external point A. AC is 14, AB is 9, AE is 18, and DE is unknown. So how long is DE? Since we don't know the value of DE, all we need to do is to assign it as X. So there are two ways on how to solve this. We could just find the value of this and subtract it to this and we will get X. But I want it to make more efficient, wherein I will be solving one example only. So to know the value of this, we know that this is 18 minus X. So if we use this, we can find the value of X for this. So let's use the formula, substitute the given, the longer one times the shorter one, the longer one times the shorter one. So let's multiply both sides of the equation, then we'll get this. Then transpose this one to the other side and this one to this side. And that gives us 18x is equal to 198. Now divide both sides by 18, we know that x is equal to 11. So DE is equal to 11 units. So this one in the figure, AE and BE are equal, so they are congruent. AC is 3AE. Then AD is equivalent to AE minus 4. Now let's try to solve this. Now what is the measure of AB? And remember, AE and BE are equal. So therefore, if we add this, we can say that the measure AE plus AE is equals to AB. So that's why we have 2AE for the measurement of AB. And we multiply it by the out external segment, that is AE, is equivalent to the value of AC is 3AE and AD is AE minus 4. So I hope that we're good with a given. Now let's multiply them to each other. We have 2AE squared. This one is 3AE squared plus minus negative minus 12AE. Now let's change AE to X so that we will not be confused. Now let's subtract 2x squared on both sides. That's how I want to go with this one. So now we have this, and we factor this out, and we know that x is equal to 0 or negative, or x is equal to 0 and x minus 12 is equal to 0. Then x is equal to 0 and x is equal to 12. Now since there will be no zero length, so x is equal to 0 is an extraneous solution. So we will find now the value of all the seconds. Since a while ago we substitute x to AE, it's now for us to resubstitute AE to x. So this will be the length that we're going to consider. Now let's find the segments first. First, let's go with segment AB. We know that AB is AE plus EB. And these sides are equivalent to each other, so we have 12 plus 12. So AB is 24. Now let's go with EC. AC. AC is 3AE. AE is 12, so AC times 12 is 36. So that's how to answer, that's the way to answer this question. Okay, let's answer more questions about power theorem. Let's start with letter A. SL is 12, DL is 18, SU is, so that gives us the whole segment as 30. Now SU is 15, then SB is unknown. So all we need to do here is to get 30, 12, multiply 30 by 12 is equivalent to 15 times x times SB. So we have this. 12 times 30 is 360. 15 times SB, so we have 15 divided by, on both sides, that we have SB is equal to 24. I should say divide both sides by 15, sorry. Now SL is 6, DL is x. Now, if you imagine, how can we get the measure of the totality of the segment? So that is x plus 6 or 6 plus x. Now BU is, SU is 8 and BU is 18. So therefore, SB is 26. Now let's find the measurement of DL, or let's find the measurement of x. So we have that 6 multiplied by 6x is equal to 8 times 26. So that is 36 plus 6x minus 36 on both sides. We have this. And divide both sides by 6. So 172 divided by 6 is approximately 28.67. So therefore, DL is 28.67. Last, for this theorem, we have SL as x, DL as x plus 2. Now, if we're going to compute for the totality of the segment, that is 2x plus 2. BU, SU is 5, BU is x plus 2, so the totality is x plus 7. Now let's find x. Let's equate them for each other. X times 2x plus 2, 5 times x plus 7. We'll be getting this. Evaluate the equation. Then subtract 5x and 35 on both sides, and we'll get this. Then factor this out. We'll be getting the following value of x. Negative 7 over 2 is an extraneous solution, so that x is equal to 5. The tangent secant segments power theorem. Power theorem number 3, the tangent secant segments power theorem. If a tangent segment and a secant intersects on the exterior point of the circle, then the square root of the length of the tangent segment is equivalent to the product of the length of the segment secant and its external parts. So meaning the square of this, the square of AQ or QA is equivalent to BQ multiplied by the totality of the secant, CQ. So let's try to put this on an example. In the figure below, OX is 15, MX is 20. Now let's find the measurement of NX. So let's just plot in the formula. Then substitute the given. 15 times 15 is 225. 20 times NX. So let's divide both sides by 20. Then we will get NX is equal to 11.25. In the figure, BS is tangent to circle T at S. So let's solve for the following. Let's start with letter A. BC is 8, CU is 10, and let's find BS. So again, it is worth noting that the totality of the segment is 18. So we have BS squared is equal to BC plus times BU. So 8 times 18 is equivalent to 144 squared both sides. BS is equal to 12. On letter B, BS is 6, BC is X, and CU is X plus 1. Now the total length of the secant is 2X plus 1. Now let's square this is equal to X times 2X plus 1. So this will be our equation. So we have this quadratic equation. Let's put this all of this on the other side. Let's put this on this side pala. So we have the value of x would be x is negative 9 over 2 and x is equal to 4. 9 over 2 is an extraneous solution, so we will get x is equal to 4. Now let's find BU. The measurement of BU is 2x plus 1. So that substitute 4 to x, that is 2 times 4 plus 1, that is 8, 8 plus 1, and BU is equal to 9 centimeter. So that's all for this tutorial of power theorem. I hope you learned something. See you and thank you, and see you on our next video tutorial.